Hi class, so this is Professor Tyler Maley here to make a video over this section, which is 1.12, looking at percent change, right? So in the previous lesson, um, in this class, you would have just looked at just basics of percents. So now we're going to go a little deeper and look at some more applications of percentages. So this very first example deals with ticket price for one-day admission at Disneyland. So you can see we're given a graph, and we have some questions here about the graph, and this will just get us thinking about percent change. So if you forget how to calculate percent change, let me write the equation here on the screen. Right? So percent change can be found by taking the final value minus the initial value and then dividing that by the initial value. Right? So essentially we're looking at the difference between the two values, and then we're always comparing it to the initial or the original value, right? We want to that's our base, right? In that sense. So this very first problem, we'll need to use this. So we want to know by what percent did the ticket price increase from 2014 to 2015, right? So first of all, if we follow up the graph. So 2014, we're at $96, right? And 2015 would be here in the center. And notice that this next data point matches up with that. Right, so in 2014, the ticket price was $96. And in 2015, the ticket price was $99. Right, so we went from $96 to $99. And I want to calculate, well, what was the percent change there? So, following our formula, right? So for percent change, let's come over here to the right here, right? So for percent change, we want to take the final value minus the initial, all divided by the initial value. Right, so the final value here was then $99, right? That's what we ended up with. And the initial was, $96, right? So if we just fill these in, right, we get what, 3 over 96. Right, so if I take 3 divided by 96 here in my calculator, right, I can get a decimal approximation. So this is 0.03125, right? But something you want to be careful with is we don't want to put a percent sign here, right? That's not the case. Don't do that. A good rule of thumb is whenever we're working with an equation, your answer is going to be in decimal form of a percent, right? So one thing when you looked at the basics of percentages, you would have noticed that there's different forms that a percent can be in, right? It can be in decimal form, fractional form, or percent form, right? So this is in decimal form. Right, so it's important to remember what form we're in. So if we want to be able to put an answer here in a box and there's a percent sign afterwards, I need to convert this, right? So an easy way to do this is I can multiply by 100%, right? So if we have a number and we don't have a percent sign and we want one, you can multiply by 100%. And remember, 100% is just the same thing as 1. So by doing so, I'm not changing the value of the number, right? So if I come over here to my calculator, multiply by 100, we get 3.125%, right? Or about 3%, right? So then the answer here, what percent did we increase by, right? So an exact answer would be 3.125%, which is roughly 3%, right? So we had roughly a 3% increase here, right? So then part B says, let's use our answer from part A to forecast the ticket price in 2016 to the nearest dollar, right? So in other words, let's assume that there's a 3.125% increase, right? Then we want to know what's the ticket price then, and that we would estimate in 2016, right? So we're assuming that we're going to have the same percent increase, right? So to figure this out, I would take $99 times 3 times 0.03125, right? So we could do that. So this part will calculate the increase, right? So you can kind of think of it as like tax, right? So like if I'm buying something that's $99 and maybe this is the tax amount, right? Then this would be the how much tax I pay, but I have to pay tax and then also pay for the item still, right? So we would have to add back in 99 as well, right? So this whole equation would calculate the new ticket price, right? So, for example, let me just take 99 times 0.03125, right? You can see that this amount is very small, right? It's about $3.09 roughly, right? If we round to the nearest cent. So that represents that increase amount, right? How much I add to the ticket price. So then if I take this and add 99 to it, then I get the new ticket price, and we were asked around to the nearest dollar, I believe. So this would be just $102, right? And again, that's rounding to the nearest dollar, right? There's actually another way that we could have calculated this. So let me scroll over here to the left. Just recall one way we did this. Is here, right? So we're basically trying to find what's the new price if we have a 3.125% increase, right? So we did this and got roughly $102, right? And this equal sign with a dot above, that just means approximately, right? So you can do an equal sign with a dot above, or you can do like a squiggly equal sign, right? And this just means approximately, right? All right, so that's one way that you can do it, right? So method one, and we're going to look at both of these methods and throughout this lesson, right? So this is the first method we looked at is referred to as a two-step method, because we had to calculate this amount and then add 99 back in, right? So essentially there's 2 steps involved. Method 2 is a one-step method, and we use what's called a multiplier, right? So if we think about this for a moment, I'm going to pay 100% of the ticket price, but then I'm adding in 3.125%, right? So in other words, what I end up paying is 103.125%, right? So again, you can think about, I'm paying like 100%. This is my increase, right? So this is like my original amount, and then I have to pay this increase as well. So this is how much I end up paying, right, in the end, which is 103% roughly, right? So what we can do is I can just take 1.03125 and multiply that times 99, and that will also give me roughly $102 increase, right? And you might be wondering, where did I get the 1.03 from? I just converted this to a decimal, right? So it took that percentage and converted it to a decimal, right? So this amount corresponds with a 3.125% increase, right? So again, let me just plug this in my calculator here. So if I take 1.03125 times 99, you'll see I get the same amount as before, right? And rounding to the nearest dollar, we get $102, right? So either method is fine there, right? We'll explore these more, right? So the general idea with these lessons, at least from this particular source, the explore part is to get us thinking about the material, and then there are oops, let me use my mouse here. And then there are some guiding questions here to think about what's in the lesson, and then this particular source is a work text, so you'll notice there's some like workbook type or textbook type information, but then also like some problems for you to complete. So that's why we call it a work text. It's like a workbook / textbook, right? All right, so then we just have one part left to finish here. Excuse me. So it says between 2000 and 2015, by what % did the ticket price increase? Right. So if we look at the table here, we have this data point, which is $43, right, in 2000. And the other one we were looking at is this data point I already highlighted here, which is the $99, right? So in 2000, the ticket price was $43, and in 2015, the ticket price was $99, right? So if I just plug this into my equation before, right, so I take the final amount minus the initial divided by the initial, right? Then this gives me what, 56 over 43. So if I plug this in my calculator, right, 56 divided by 43, we get roughly 1.3023, right? And we were asked by what % did the ticket price increase, right? And don't forget, this part's in decimal form. So if I want to put this in % form, I just multiply by 100, and we get roughly 130%, right? So we could say roughly 130% is how much the ticket price increased, right? So from 2000, which is the beginning of our data, till the end, 99, we experienced roughly 130% increase, right? All right, so here you can, so I won't necessarily go over all the workbook or the textbook type material just for time, right? So you can read over this and see, what are the main goals and so forth, right? So this next part is highlighting the one step and the two-step method, right? So again, you can read over that, and there's a nice visual here, and we'll talk about some of these things, right? And there's this idea of a multiplier, which is important, which we'll talk about. So to figure out the multiplier, if we take 1 plus the % as a decimal, we'll get what's called a multiplier, so we know what to multiply by, right? So let's work through this a little bit. So number 2 is a good example of this, right? So remember, to find a multiplier, you're going to take 1 plus the % in decimal form, right? Is how you're going to come up with this, right? And we want to think of positive as a % as increase, right? And use negative if the % is decreasing, right? So again, if you have a percent increase, you make your decimal a positive, right? And if your number is decreasing, we're going to use a negative for the decimal, right? So for 2a, if I'm increasing by 22%, right? So first thing is 22% is equal to 0.22, right? That's what that is in decimal form. So for part A, if I'm increasing, to find the multiplier, I would take 1 plus 0.22, right, which is 1.22, right? So for part B, we have the same number, but notice it's decreased. So if I'm decreasing, I would take 1 minus 0.22, which gives me, what, 0.88. Right? So these are known as my multipliers, right? So notice something to point out is if my number is bigger than 1, that means I'm increasing, right? Which makes sense, right? If I take a value and multiply it by a number bigger than 1, that number is going to grow, right? But if I take a number times a number less than 1, that's going to get smaller, right, or decrease, right? So you should recognize that, right? So if we want to put that in terms of words, right? So here I'll just put my multiplier here, and then we'll put what happens. So if I pick a number that's less than 1, right? If my multiplier is less than 1, what happens is we get a decrease, right? If I take it times a number bigger than 1, right, greater than 1, then we have an increase. And then lastly here, let's look at what happens if it's equal to 1, right? Then that represents no change, right? So if I take any number times 1, I just get itself back, right? So if my multiplier is just 1, that means I didn't have a percent change, right? And you can think about it as 1 can be written as 1 plus 0, right? And remember, that is my percent change, that part, and how to calculate that. So if 1 is my multiplier, then you can easily see that 0 would be the percent change, right? If you think about that a moment. All right. So then this next part is saying how it works, and again, this is just more of a textbooky thing. So it's telling us to apply a percent change, we can do it using one of these two methods, right? So option 1 is known as the two-step method, and option 2 is referred to as the one-step method, right? Using a multiplier, right? So you can read over that, and there's some examples to look over as well, right? So that's for increase and decrease. So number 3 is a really interesting example, right? And this could actually happen. It says, at your job, there are 2 proposed pay raise structures being offered by management to the labor union, right? So option 1 is a 5% increase, and option 2 is a 3.5% increase, and then you get a $1,000 bonus, right? So it's important to be able to an easy apparent way that math is very useful is just with finances, right? That's a very direct application, and a fairly big part in quantitative reasoning, which you should be covering right around now, right, in chapter 4, right? So this scenario is very useful because if I was in charge of this labor union, I would want to see, well, how does this affect people and so forth, right? Money is very important. You don't want to take a option that you're going to end up making less money, right? Obviously, the goal for most people is to make more money, right? So on the next page is this little table here that we're asked to fill in. So to save time, I already pre-typed this table into an Excel document here, right? So first thing we're asked is just to calculate this. So let me see if I can do just a little split screen here with my OneNote here. So I might want to write down a few notes as we're figuring out the Excel equations, right? So Excel is just really a really useful tool, especially with something like this option, right? So certainly we could do any of this work by hand or calculate for each person, but let's say you have 100 people in your labor union, right? That would become a very time-consuming task. So Excel, as computers do, is just increases the efficiency with doing such, right? So so if I want to figure out what equation would go in cell C2, right? So we want to take the this is the so what we're calculating here is option 1, which is a 5% increase, right? So remember, so if I have a 5% increase, my multiplier would be 1 plus 0.05, right? 0.05 is 5% in decimal form, so 1.05, right? So in other words, I want to take $15,000 and multiply by 1.05, and that will give me my new salary amount, right? So if I take salary times 1.05, this will be my new salary for option 1, right? So if I wanted to show this in variables, which will be helpful because I'm going to show you a visual here in a moment, is let's say I let y equal my current salary and x equal or excuse me, I want x to be the current salary. So let me just erase this here. And I want y to be my new salary. Right? Then if I wanted to show this equation, salary times 1.05 equals new salary, option 1, right? I could show this as y equals, right, 1.05 times x, right? So that this equation is the same thing as this equation, right? So this one's more in word form. This is just more symbolic, right? So let me just save this here. So this is option 1. Right, so we can refer back to this, right? So in Excel, right, I can do this, right? I can just hit equals and then click on this box, right? I want to take this whatever number's here and multiply times 1.05, right? And I get that amount. And now what I can do is I can just pull. If you notice, if I put my cursor in this box, I get this plus sign. Now if I just pull this down, it'll do that all the way down, right? So like if I double click here, it'll show you it's taking whatever values to the left times 1.05, right? So that's exactly what we'd want to do all the way down, right? So like to get this cell, I would take 40,000 times 1.05, which is what's going on here, right? Another thing I can do if I want to make this, I don't know, look a little neater, I could highlight this and go to home, and I can click this dollar sign here that you see, and that will just make it look like money, right? And notice I had these like let me get it back. These pound signs, that just means there's not enough room to show the number, right? So I can make that cell wider, or you can just double click and it'll fix that for you, right? And if I don't want these decimals here. There's buttons here to increase and decrease decimals, so I could, just get rid of those, right? We don't there's no sense involved, at least for this first calculation, right? But if you wanted to leave those, perfectly fine. You can just leave them in there, right? So then the new salary for option 2, notice the order here. We have a 3.5% increase, and then you get an extra $1,000, right? So it's important to understand the order, because you don't get the $1,000 first and then a 3.5% increase, which would actually give you more money, right? Because what you're doing is if you get the $1,000 first, you're increasing your money, and then applying a percentage increase on top of that. So that would give you more money, but that's not the scenario here, right? It says very clearly that you get a 3.5% increase and then $1,000, right? So if I wanted to write this same thing but in words, right? So option 2, right? It would be my new salary equals. So I have a 3.5% increase. So my multiplier would be 1.035. Right, and this would be times my current salary. Oops. Right, and then plus 1,000. Right. So let me just make this a little wider here for a moment. Right. So that's option 2, right? So this part is doing the percent increase, and then we're adding in $1,000, right? So if I want to write this in symbols like I did above here, this would be y equals 1.035 x plus 1,000, right? So this would be option 2. Right, so I'll just bring this back over here. Right, so this was option 2. So now we can go ahead and plug this into Excel, right? So if I want to calculate the new salary, I want to take my current salary, which is this box, right, times 1.035 plus 1,000, right? So if I hit enter, it'll calculate that amount, right? And I can again put my cursor there in the corner and drag this down, and that will calculate them all the way down for me. And I can click on this $sign to show this as money, right? Right. So you can see those values all the way down, and then this next this last row is just the difference. And notice the order. It says option 1 minus option 2, right? So what I'd want to do here is do option 1, so this value, minus the option 2 value, which is this cell D2, right? So if I hit enter, it calculates that, right? And I can fill this down all the way, right? And in the formatting I'm in currently, since I'm in the accounting format in Excel, negative numbers are shown with parentheses around them, right? So since this number here, this $775, has parentheses around it, that means it's a negative number, right? So in other words, what it means is in word form is that option 1 is less than option 2, right? If I'm taking option 1 minus option 2 and I get a negative number, it means my first number was less than the second number, right, that I'm subtracting, right? And you can see that that's true here all the way down, right? So it's like here this is positive. You can see that it's because this number is bigger than this number, right? Option 1 is bigger than option 2, right? All right, so we have our nice table here. So I'm just going to take a screen. I'll just take a screen capture of this really quick. And have that here available. Right. So let me just put that picture here to reference. Right. So so we have our table filled out. Right. So number B says let's list the names of the employees who benefit more from option 1 and those who benefit more from option 2. Right. So remember, if we go back to this table, right? If someone benefits more from option 1 or option 2, right, it means they're getting more money, right? So if we pay particular attention to the difference, right, all of these values are negative, right? This means, again, that option 1, so option 1 is less than, excuse me, I meant to put a less than there. Right? Is less than option 2. Right? That's what a negative sign would mean. So so all these people are benefiting from would benefit more from option 2, right? So these would benefit with option 2. Right? So then now we need to think about, well, who would benefit from option 1? Well, that's these guys here, right? Evelyn and Emily, that have a positive. So since they have a positive here, right, that means that option 1 is greater than option 2. Right, because we're subtracting option 1 minus option 2. So so this part, so these guys, Evelyn and Emily, would benefit more from option 1. Right, so you could write those lists down, right? So you can see who would benefit from each one. Right? So for letter C, it says, what does the result in the difference column mean for John and for Emily? Right? So if we look at option C, right, or part C, so we want to know so if we look at John, right, so let me grab a highlighter here. So this first row is John. Right? So John has a difference of negative $775. We want to know, what does this mean? Right? What this means is that John maybe work better if I just type this here, right? As we're write a full sentence. So we could say that John will make $775 less under option 1 than with option 2, right? That's essentially what that means. And I can make this a little bigger if you'd like. Right? Right. So again, we're just thinking about, because if this difference was 0, that means they'd be making the same, right? So since this was a negative number, it means I'm going to make $775 less than under option 1 than with option 2, right? And you can verify by looking at the two amounts, right? If we take this number, add $775 to it, you'll get this amount, right? Option 2. So then the next part was looking at Emily, right? So Emily was the very last one here. So Emily has positive $425, right? So again, if you think about a minute, that means, again, as we looked at before, that option 1 is bigger, right? So if we wanted to write this in words, right, so we could use like a similar sentence structure. We could say that Emily will make $425 more under option 1 than with option 2, right? Right, so that's what that value means. So then part D, right, part D asks us to look at, in general, which salaries benefit more under each option, right? So if we look at what's the difference here under the salaries, notice the current salary column. It's actually in order from smallest to biggest, right? We start at 15 grand and go all the way to 95,000. So if we look at, in general, who's benefiting under option 2, you'll notice that it's the people that are making less money, right? And then suddenly, in between $60,000 and $80,000 here, there's like this switch where suddenly the option 1 increase is benefiting us, right? We get more money from that option, right? So that's what we could say with this in general item, right? So maybe we could say something like lower salaries do better with option 2 and higher salaries do better with option 1. Right? So that's just a general statement. So then if you're looking at part E now, right? So I haven't, not writing on this page now, so I don't feel like I had enough room to write, at least not for making this video. That's why I've kind of fallen off this, right? But you could be filling this in as we go, right? So now we're in part E. So is there a salary for which the two options would be the same? Explain how you can logically find that salary. So the easiest way to do this is actually thinking about this algebraically, right? That's why I made these two equations here, right? So let me go to a website. I'm just going to go to Desmos graphing calculator, right? So this is just a free website you can go to graph some functions. I'm just going to come here, and so the first, so if you go back and look at the notes, right, we had 1.05 x and this equation, right? So that's what I'm going to be plugging into Desmos here. So we have y equals 1.05x and y equals 1.035x plus 1,000. and we get two graphs. So let me just zoom out so we can see both here. All right, so that's not a very good window. Let me see if I can modify this, make it a little easier. All right, so with the X, maybe let's go 0 to 10,000, maybe go by 1,000 each time. And then the y-axis, well, hang on. Sorry about that. I need to make this bigger. I need to actually go. All right. All right, so I had a good idea to graph these in Desmos, but which you can see the functions okay, but it's hard to get a good window to emphasize the kind of picture that I was wanting to emphasize. So I'm just going to kind of freehand this, and I'm going to emphasize the slopes a little more than they actually would, so that way you can visualize a little better what I'm talking about, right? Because the 3.5% and the 5%, they're so close, which would be the slope of the lines. It's kind of hard to see with that graphing utility. So again, let me just kind of freehand this a little bit, and these aren't going to be like to scale. They're going to be a little more emphasized, right? So if I wanted to graph the first function y equals 1.05x, right? Y equals 1.05x, then I know this point's going to go through the origin, right? Because I have like a plus 0 here, right? This is in the form y equals mx plus b, right? So from your algebra days, right? The b value is my y-intercept, and the m is my slope, right? And I have a positive slope, so it's gonna go through the origin and just increase, right? Like such. Right, so that's that function, and then I'll go ahead and let me change colors here. Do the next one. So the option 2, right, was y equals 1.035x plus 1,000. So the y-intercept, right, the b value is 1,000. So if I come up here to 1,000, that's going to be my first point. And then I'm going to have my line is going to be less steep than the 1.05, right? Because it's only increasing by 1.035. So it's not going to be as steep, but so maybe a little flatter, right? So the important part that we want to think about is there a point at which the options would be the same is the question, right? So visually, graphically, it would be this point here, right? At this point, right, option 1 equals option 2, right? So in other words, there is a salary. If I made this amount of money, I wouldn't care if I got option 1 or option 2 because my increase would be the same, right? So that can exist. And notice, from $0 up into that point, this blue line, right, is less than, right? All the blue points are below, right? These are below the red points. So this is showing option 2 as better until you get to this point, and then notice what happened. The blue is now above the red, right? They kind of switch. So after this point, option 1 is better, right? So again, that's just a rough sketch just to illustrate what I was trying to illustrate. And sorry the Desmos didn't quite work out how I had planned. Right, so we can actually find this value, right? We can do it algebraically pretty easy. So we can just use this idea, option 1 equals option 2, right? In other words, set their y's, y equal to each other and figure out what x value would make their y's equal, right? So option 1 we had 1.05x, and option 2 we had 1.035x plus 1,000, right? So there's option 1 equals option 2, and we just need to solve for x. So I can subtract 1.035x from both sides, right? And this would give me, 0.015x equals 1,000, right? So then what we would need to do next is divide by the coefficient, right? So divide by 0.015 to both sides. Oops, I didn't mean to write an X there. So this left-hand side is just X, and the right-hand side, so if we take 1,000 and divide it by 0.015, we get $66,000. So we get 66,666, and if we round to 2 decimal spots, we get 67 cents. Right. So we round to the nearest cent, we get this amount, right? So that would be the value here, right? Right, and we found that by setting the equations equal to each other. Right. So then lastly, part E, or excuse me, we just did part E. Part F says state the salary range of employees who would benefit more from each pay raise option, right? So if we use that information in my chart, right, we can figure this out, right? So let me just bring your attention back to this graph. Right. So if you make, 0 to this $66,000, which option is better? Well, option 2 is better, right? Because that's this part of the graph, right? The red's above the blue. Now, after we switch, we want to see, well, what option's better? Well, that's option 1, right? So if you make more than 66,666 and 67 cents, right, then option 1 is better. Right. So option 1 higher than the $66,666.67, and then option 2 is just less than that amount. We would benefit more. Right. All right. So let's move on here. Try to finish this up. Right. So again, just to save time in the video, I won't go through all this in depth. You can read over that. And there's a worked out solution. Right, but I just want to mention here under the how it works. So this is just a way to calculate percent change, right? So there's 2 ways to kind of figure that out, and you can see, and there's some examples there to help you figure that out. So if we look at 4a, this is kind of the opposite of what we did previously. Before we were given a scenario and asked to come up with the multiplier. Now we're given the multiplier and asked to figure out the interpretation, right? So 1.37, right? Again, this is bigger than 1, so I should automatically be thinking that's an increase, right? So if I take 1.37 minus 1, I get 0.37. So that's going to leave me with the percentage, right? So 0.37 is equal to 37%, right? So for 1a, right, that's going to show a 37% increase. Right, so here we could just say 37% increase, right? And then we can do the same thing along here, right? So 0.51 is less than 1, this you should automatically be thinking a decrease, right? So again, if I take 1 minus 0.51, we can figure out that difference, which is 0.49, right? Which is 49%, right? So this would show a 49% decrease, right? All right, so then this next example, we're given a scenario with a husband and wife, maybe doing some weight loss. We're asked to fill in this table and then answer some questions based on the table, right? And we're recognizing if each statement's true and false. So just to fill in this table, right, if we figure out the pounds lost, we just need to subtract, right? So 380 minus 366, right? So I can pull up my calculator here. Right, so if we just take 380 minus 366, right, we get 14, right? So we lost 14 pounds, the husband, and then do the same thing, right? 200 minus 190, that's just 10, right? You can plug that in if you want. And then we're trying to calculate the percent of weight lost, right? So I started out at 380, so this is my initial, and this is my final, right? So then these pounds lost, right? This is my initial minus my final, right? So think about the equation of percent change. We take the initial minus final divided by the final. So I just need to take 14 divided by the 380 then, right? So if I take 14 divided by 380, we get about 3.7%, right? So if I multiply this times 100, I can put that in percent form. So we're getting roughly 3.7%. Right, because notice the unit here emphasizes percent. Right, and if I do the same thing for the wife, I would take 10 divided by 200. Right? And again, I can multiply that times 100, take that from decimal form into percent form, and we get 5. Right? So the wife experienced a 5% decrease of weight loss, while the husband had a 3.7%. Right? And notice the husband lost more weight. Right? The husband lost 14 pounds, the wife lost 10, but the wife had a higher percentage lost. Right? So we wanted to say which is true, right? The husband lost more pounds. So true or false? Well, that's true, right? The husband lost 14 pounds, which is bigger than 10, right? So that's true. Part B says the wife lost a higher percent of her weight. Well, that's also true, right? So if we take and compare, 5% is bigger than 3.7%. So that's fine to say, right? Part C, the wife's new weight is 95% of what it was originally. Well, if you think about this for a moment, this is also true, right? And you can kind of see easily. So of, typically means times in math, right? So in other words, what they're saying is the wife's new weight, right? So in other words, the wife new equals, right, means equals 95% of, so 0.95, right, is 95%, and then we have times, or the original, right, so the starting weight, right? If we think about this for a moment, if she had a 5% decrease, the multiplier would be 0.95, right? So this 0.95 is the multiplier, so that works out, right? That's literally what 5% decrease means. So then part D says the wife's starting weight was 5% more than her ending weight, right? So this is actually false, right? And the reason why it's false is that there's a changing base going on here, right? So base is what we base the percentage on, right? So if this is trying to do it backwards, right? If I take 5% times the starting weight, which is 200, right? This will give me 10, right? This is the amount lost, right? So she lost 5% of her previous weight. But this is saying the wife's starting weight was 5% more than her ending weight. So this is trying to go backwards, right? If I take 190 times 5%, then this is supposed to equal this distance in between, right, or this 10. But this doesn't, in fact, equal 10, right? If I take 190 times 5%, 0.05, right? You'll notice I get 9.5. So here this actually equals 9.5, which is not equal to 10, right? So before, we weren't rounding to be 9.5. It's exactly equal to 10, right? If I take 0.05 times 200, I get exactly 10. So we can't do this in reverse, right? Because it's a different base amount, right? Or if you relate it to money, right? Let's say we have a 5% tax. You can't change the amount and still pay the same tax, right? So in other words, this first scenario, let's say you're buying, I don't know, a TV for $200, right? And the tax rate stays the same. You're going to end up paying more tax than if you buy a TV that's $190, right? So you can't just change the amount of the product, if you will, and why the tax rate stays the same. Your actual amount paid in taxes is going to be different, right? All right, so then looking at number 6 here, it says the price of an item in an online auction goes from 200 to 400. Determine which of the following statements are true. So again, it's more of a true-false thing. So we're going 200 to 400, $200 to $400. Right. So part A says there was a 100% increase. Is that true or false? So this is true, right? So in other words, what it's saying is if I take 200 plus 100% times 200, does this equal 400? And it does, right? So this represents the 100% increase. Right? So then we can look here. It says part B that the new price is double the initial price. Well, this is also a true statement, right? So if I take 200 times 2, we get 400, right? So that's true. Part C says there's a 200% increase. So this is actually going to be false. Right, so doubling is not the same thing as a 2% increase, right? And it also makes sense if we compare part A and B, or excuse me, A and C. The only difference listed is the percent amount. So how can you have a 100% increase and a 200% increase be the same thing, right? So if you think about it for a moment, a 200% increase, what this would mean in numbers, right, is we would take $200, right, my original amount, and add the increase, which would be 200% times times my amount. So this would end up being 200 plus, so 200% I can write as 2, right, 2 times 200, which would equal, well, this would all equal, what, $600, right? So you can see it actually ends up tripling, right? So if you have a 300% increase, 300%, or excuse me, a 200% increase, that's the same thing as tripling, right? So if you have a 100% increase, that doubles, right? So this question is just meant to try to get rid of that misconception that some people have, right? So then part D says the new price is 200% of the original price, and this is also true, right? So we can investigate this a little bit. So this would be the new price, right? Is means equals 200% of means times the original, right? Well, the new was 400. 200% I can write as the number 2, right? So just putting that in decimal form, of means times, and then original was $200, right? So this is in fact true, so that makes that statement true, right? So I just took that sentence, broke it out as an equation, and just to verify that that's in fact true, right? All right, so we have one last question here. So it says a college raises tuition each year by the percent noted in the table. So we have given years and the percent increase, and we want to find the overall percent increase in tuition from 2012 through 2016. So really what this is trying to get at is, notice we don't know like the actual dollar amounts or what we started with, but we were just given these percent increases. So if you want to find 7a, it turns out we can't simply just add all these percents together and get that. And that's because the amount is changing each time, right? So let me maybe just throw this into an Excel document really quick. So I'm just going to pause the video here while I type this. So I'll join you in a moment. All right, so I just threw this information in a quick table here. Right, so you can see that I just typed this in, but one thing I added is I'm adding a column called new tuition. So what I want to think about to begin with, to kind of convince you of this, is let's just say, since we don't know amount, we'll just say $1,000 just for a nice simple number to start with. So what I'm saying is, in 2011, let's say tuition was $1,000. Then how would we calculate the new tuition in 2012, right? So if we wanted to do this using Excel, right, we would take 1,000 times 0.08, or excuse me, 1.08, right? Because an 8% increase, the multiplier would be 1.08. So this would give me 1080, right? So then I can keep doing that, right? Let's take the previous number. So 2013, I would have a 5% increase off of the $1,080, right? So if I take the previous amount, multiply by 1.05, because I have a 5% increase, I'm getting 1,134, right? And then so forth, right? So now I'm getting a 9% increase, so I multiply by 1.09. Whoops, I forgot to hit the times. And we get this amount. And then same thing, take the previous one and we would multiply by 1.13 this time because we have a 3% increase. And then lastly, we would take this times 1.07, right? Because we have a 7% increase, right? So that's what we get. So you could calculate this by hand as well. You get the same amount. Right? I was just trying to speed things up, make it a little neater. But I can throw the screenshot here, right? And you can see the amount, right? So again, the important part is for this year, maybe you make a column for the base, right? So remember, the base is what the percentage is calculated off of, right? Or like your purchase price, what your tax is based off of, so forth. So with the year 2012, if we start off with $1,000, my base is 1,000, right? And for 2013, my base would actually be whatever the tuition was in 2012, right? So in other words, this would be year 2011, right? The $1,000 is the amount in 2011. So the base for 2013, what this is calculated from, would be the cost in 2012, right, and so forth. So this would become the 1080. The next one would be the 1,134. And then the next one would be 1236.06, right? And then the next one would be 1396.7478. Right, so each base is of the previous year. Right, so this is why we consider this. We have what's known as changing bases. Right, so that's why we can't simply just add up all these percentages. So if you wanted to figure this out really quick, maybe the easiest way to do this is you could take and just calculate percent change from this amount to this amount, right? So we would take 1494.52015, right? Take the right. So if you go back to the original equation I wrote on the page, right? We took what the initial value minus the final value, all divided by the initial value, right? So let me just write that back up here. So for percent change, we had a final minus initial, all divided by initial, right? So that's what I'm visualizing in my head when I'm doing this, right? So if I take the 1,494.5205, that's my final. My initial would be the 1,000, right? That's what I started out with. And then divided by my initial value, which was 1,000, right? And again, I just made up this 1,000 number just for ease. You could pick any number you wanted, and you would still get the same percent increase in the end, right? As long as you make these calculations right. So if you plug this in your calculator, right, you should get 0.4945 roughly, right? There's some more decimal points here, right? But we're close enough. So the question asks for percent, though. So if we round this to a percent, this is approximately 49.5%, right? And notice if we add all these up, you don't get 49.5, right? If you add these up really quick, you get 42, right? So that's a difference. Right, so here we would just have approximately 49.5%. For part B, adding the percent change for each year will not result in the correct percent change. Why is that? Again, we talked about that as the bases change each year, right? So because the bases change each year, right? It's not staying the same. Part C says, is there ever a time when we can add the percents? So yes, there is. Right, so we could say yes if we are finding the percent of the same number each year, right? So in other words, when we have the same bases, that's okay, right? All right, so this video is up to an hour, 11 minutes, so I think we're good to finish. So we're done with this lesson. If you have questions, please post questions on Canvas. Thanks.